All right, now we're going to get into some kind of odd stuff. Euler's formula takes a real number, theta, and it converts it into something dealing with the letter E, right? So this cosine theta, the cosine theta plus I sine theta, right? Remember, this is our original, the r cosine theta plus I sine theta. We're going to leave that r out here. So if we're looking at just replacing the cosine theta plus I sine theta, that replacement is actually e to the I theta. E to the I theta. I know it looks funny. So the formula, if I want to go ahead and substitute for r cosine theta plus I sine theta, which is our polar version, is going to be r times e to the I theta. So this is actually called our exponential form. This is our polar form. So there are times where it may ask you for both the polar form and the exponential form. So the equation that we just did, right? We knew our r was 6 and we knew our angle was 5 pi over 3. That was from page 1. If you didn't see us work through that, go ahead and go to the previous video. In order to put it in exponential form, then we are going to do r, let's see here, I'm going to write it here first, I theta. So this is the form we want. So we want 6 times e to the I 5 pi over 3. And yes, we're going to have a fraction in an exponent. That's fine. All right, so here it has us plotting a point on a complex plane, and then we're going to convert it back to rectangular form. So we're going to go the opposite direction. All right, so we're going to find r, and we're going to find theta, and r is going to be 3, right? R equals 3, and theta equals 60 degrees. So we can pull that straight from the equation. And again, instead of 60 degrees, you might have pi over 3. That's fine. Okay. So we're going to use r and theta to plot in the complex plane. No problem. I'm going to actually write that over here so that I have room to do my conversions over there. Okay. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So my R is 3 and it's at 60. So it's about somewhere in here. It falls a little bit short of the other. So 3 and 60 degrees would be my plot there. Okay, now it wants me to convert it into rectangular form. And so I'm going to go ahead and actually do that over here under section B. And remember that x is equal to r cosine theta. X is equal to r cosine theta. So r is 3, and then cosine of 5 pi over 3. Now when I take a look at my unit circle, 5 pi over 3 has an x value of 1/2. So that's going to be 3 times 1/2. Actually, negative 1/2. Nope, it's positive 1/2. It's negative root 3 over 3. Okay, so positive 1/2, and then that would be 3 over 2 is my x value, so that's completed. And then for my y value, right, that's going to be r sine theta. So that would be 3 times the sine of 5 pi over 3. And so we have 3 times negative square root of 3 over 2. And again, I pulled that off of my unit circle. And this, when I go ahead and put it together, is negative 3 root 3 over 2. So that's my y. So when it asks for my rectangular, that's going to be 3 halves, comma, negative 3 root 3 over 2. So that is my rectangular form. So again, you've done this before. This is nothing new for you. Okay, so now we're going to do a little exercise in using the exponential form of it to find multiplication and division of these complex numbers. So we have two of them. Z1 is R1 EI theta 1, and Z2 is R2 E, this is an I, theta 2. Okay, that's an I and that's a theta. And what we remember from multiplying numbers that have exponents is that you're going to add the exponents, right? So when I have these two things that are multiplied together, that's going to give me, R1 times R2 times e to the I, and then it's going to be theta 1 plus theta 2. Now, if both of my r's are the same, it would be r squared, I 2 theta, if my thetas are the same. In this case, it's not, but because we can't guarantee that, right? So I would just add those angles together. And then if we want to do division, same rules apply, right? We would have R1 over R2, and then here it's theta 1 minus theta 2 with that I hanging out in the front. So with division, we're going to subtract our angles just like we do with normal numbers.